Welcome to video 6, dividing with exponents. So we have this question on the first one, x to the fifth divided by x squared. This can also be written as a fraction, so remember that division is a fraction. So x to the fifth divided by x squared. This really means if we were to expand it out, we would have x to the fifth written as x 5 times. X times x times x times x times x. X squared is x times x. If we look at this, well, we know anything divided by itself is 1. So where we see an x on the top and an x on the bottom, we can cancel those things out. So this x would cancel with, say, this x, and this x would cancel with, say, this x. So now we'd be left with how many x's? Well, we could count them, 1, 2, 3, so that's x to the third, nothing on the bottom, so I can either put divided by 1 or just plain old x to the third. So we need to remember here that anything divided by itself is 1. So we have a dividing rule for exponents. Rather than having to expand it out every single time, we can remember this rule, and that's that if we have x to the a power divided by x to the b power, it's going to always equal x to the a minus b power. So when bases are the same, with division, the exponents are subtracted. So in this example, what if the exponent on the top is smaller than the exponent on the bottom? So similar to what we did in the previous example, we expanded it out. So x to the third was written out 3 times, x times x times x, x to the fifth 5 times. So we'll do the same thing. Anything divided by itself is 1, so they essentially cancel. So this will cancel with this first one, the second one will cancel with the second one, the third one will cancel with the third one. Well, we're left with 2, but this time they're on the bottom. So in this case, it's very important to put the 1. In the original example we had, I didn't have to put this over 1 because it's the same as just writing x to the third. But if I just write the answer x squared, that would not be correct because this is not equal to x squared. It's actually equal to 1 over x squared, or 1 divided by x squared. So that's our answer there. Okay, so the next question says negative exponents. There's a procedure to change negative exponents into positive exponents because we never want negative exponents. Never, never. So this is the basic formula. When we have x to the negative n power, we have to move that to the denominator, or the opposite side of where it is. So right now it's in the numerator because we could put this over 1. So I would have to move this to the denominator. So that's what we have to do to eliminate negative exponents. So when we divide and subtract exponents, there's something important we have to remember here. If the outcome is positive, the base goes in the numerator, or on the top. But if the outcome is negative, the base goes in the denominator, or on the bottom. So it's something that we have to remember here. So you might want to highlight or star or indicate that this is something that we need to know. When we divide and subtract exponents, these are what we have to do. Okay, let's look at a couple examples. So in this first one, if we need to simplify, x to the ninth divided by x to the fifth. Well, I'm going to start by writing this like a fraction. So now I have this. I can see my numerator and denominator. My rule is that we're going to subtract a minus b, so numerator minus denominator exponents. 9 minus 5 gives me 4. So my answer would be x to the fourth. Okay, now the next example, if we have 5 on top, 1 on the bottom, again, we can write a little 1 if that helps you. Because if we don't see the exponent, it's a 1 because there's 1 of them. So 5 minus 1 gives me 4, so my answer is y to the fourth. And in this next example, I'm again going to write it out first. And when I do that, I can see that that's actually the same thing in the numerator and the denominator. And remember, anything divided by itself is 1. So my answer here is 1. So there's all my answers for this page. So there will also be times when we have a 0 exponent. So what happens if we end up with a 0 exponent is anything to the 0 power is 1. So in this first example, if I look here, if I were to do the subtraction here, 2 minus 2, that would end up giving me x to the 0 power. But remember that anything to the 0 power is 1. We can also remember here in this case that anything divided by itself is 1, but this is y. So in this next one, we have 4 times x to the 0 power. Well, it's important to notice here that only the x is being raised to the 0 power, so that part is 1. So we can rewrite that as 4 times 1, which would give me an answer of 4. So that's my answer there. But this next question is a little different. And the parentheses mean that that entire thing is being raised to the 0 power. So this whole thing to the 0 power gives me an answer of 1. Okay, that's it for this video. We'll see you tomorrow.